Kyle Bocinsky, giving us our winter drought update. So, Kyle, if you would, please introduce yourself to anyone that we have new from our other call, and then we'll get right into it.
Yeah, will do. Hi, everyone. Thank you. Thanks so much for being here. And again, Vic, thank you for inviting me to give these updates. I think it's important. We've had a lot going on since my last update, which was back in September, right? We've had major fires in California, that obviously on the coast with the Santa Ana winds that took out large communities there. In the last week, we've had both horrible fire weather in Oklahoma and Texas. We've had an outbreak of tornadoes that affected our friends out east from Missouri through Atlanta. Actually, I've got all my family's in Atlanta, Georgia, or outside of it, and they were all in their basements over the weekend. And then we're moving into a spring where we're seeing pretty dramatic drought conditions. So I'm Kyle Bocinsky. I'm the director of climate extension for the Montana Climate Office, and I've been part of the Native Resilience Project since its inception and part of the Native Waters on Arid Lands project before then. And I've been given these updates since early on in COVID days, since before 2020. I'm going to share my screen real quick so you all can see what I'm going to be talking about. And just want you all to know that we are recording this, and we'll post that recording on our website, which you can now get to at native-resilience.com. And you can get to all the recordings of this presentation. I'm also happy to share slides and all of that. Just reach out to me. I'll have my email posted at the end of this, and I bet Vicky or Kelsey can drop it in the chat as well. Here's our current picture when it comes to the U.S. Drought Monitor. This is posted last Thursday, effective the Tuesday before last. As we're looking across the country, what we have is really exceptional drought conditions across much of the southwestern and southern tier of the country, including all of Arizona in drought or abnormally dry conditions. The only part of Arizona that's not is extreme northeastern Arizona is just abnormally dry. Everywhere else is seeing a pretty substantial drought across that region. Same with the southern tier of New Mexico, and then down in the western portion of Texas and across South Texas as well. Just really exceptionally dry conditions. Keep in mind that exceptional drought, as defined by the U.S. Drought Monitor, as a rule of thumb, is a 1 in 50 to 1 in 100 year event. Should be in the lowest second percentile of dry conditions. And that's in fact what we're seeing when we look at drought across South Texas right now. Here's my video. I love this video. I'm going to zoom way forward in it, though. This is showing the last 25 years. So we've been doing the Drought Monitor for 25 years now. I'm zooming forward to the last few years where we see the development of these drought conditions as they've expanded across the southwestern U.S. Over the last several months. I'm going to go back again to last winter and just show that. Show that again, just to get a sense of where we are as we're moving into to this winter. We had a bad drought across the northern tier of the country. We've actually had some amelioration of our drought conditions across the northern tier. Northern plains, though, we're still seeing a lot of those dry conditions, especially in South Dakota and North Dakota, northwestern Nebraska here, and then western North Dakota. We're definitely seeing some abnormally dry and extreme, actually up into extreme drought D3 conditions. We're outside of our main grazing and growing periods, obviously, in the northern plains. We'll see if those continue, if those dry conditions continue into the growing season. If they do, what we can expect is to see some declarations of drought emergencies and the need for drought assistance, like the livestock forage disaster program. So why do we have these conditions? Well, let's first break it down how these conditions have sort of grown across our country. And what I do here is I want to break this down by hydrologic basin, right? Drought's a water thing. So it helps us to look at how drought is affecting our primary hydrologic basins across the US. When you see these graphs, I'm going to be mainly going from north to south. So you're going to be able to see the Pacific Northwest and the Missouri River basins at the tops of the graphs, and then our southern basins from California, Colorado, and the Southern Plains across the sort of middle tier of this graph. You can see it here. This is just since January of 2020. So this is 5 years of drought that we're looking at, a picture of 5 years of drought as we've seen drought change over this period. And here we're looking at this is, excuse me, 20 years. Here we're looking at, did I skip that? Hold on. There we go. Here's 5 years of drought. Here we're looking at the Pacific Northwest and the Missouri, California Great Basin, Colorado, and Southern Plains. What we're seeing here is that, well, we've been in drought conditions across the whole country during this entire period somewhere, but really we had a nice little break in terms of our droughty conditions, especially across the northern tier in the Southwest and the Colorado River basins during 2023 through 2024. But as we went back down into La Nina conditions, I'll get into that in a minute, and then have started emerging out of them, what we've seen is the reemergence of drought across the southern tier of our country, especially the Colorado River Basin. And this is a pattern that we see actually especially across the West, when it comes to our drought conditions. We often see drought conditions first emerge in the Southern Plains and the Colorado River basins, and then move through the California Great Basin region, the Missouri River Basin, and you can think of it as drought exiting the country out of the Pacific Northwest, out of the northern tier of the country. So we really get a nice sort of preview of our drought conditions across California and the Great Basin, the Missouri River, and the Pacific Northwest by looking at what is going on in the Colorado River Basin and the Southern Plains. And we see this over and over again. Our major drought outbreaks that we see across the country, and again, this is over the last 25 years, the major drought outbreaks that we see often originate with emergence out of a La Nina event and originate in our southern plains in the southern tier of the country, and then leave the country through the north. And that is what we're starting to see here with the redevelopment of these extreme and exceptional drought conditions in the southern plains in the Colorado River Basin. Now, we see this emergence down here. This is the amount of change that we've seen in the U.S. Drought Monitor since the start of the calendar year. So we're going on about 3 months, right, of the U.S. Drought Monitor since the beginning of the year. Already, we've seen huge amount of degradation. This is getting worse here in red. Here in western Arizona, southeastern California, excuse me, and southern Nevada. That region centered on the Grand Canyon, really, right? Centered on Lake Mead, has seen a real degradation in drought conditions. We've seen the same thing in portions of the northern plains, not up here in the headwaters where we are. It's sort of a mixed bag up here where I live, but down in western South Dakota, eastern Wyoming, northwestern Nebraska, and western North Dakota, we've definitely seen a degradation of conditions. Same thing down here in South Texas, right? Now, New Mexico is real bad right now, but New Mexico has also been real bad for a couple, I mean, for a long time. For over a year now, we've seen drought conditions in western, actually across New Mexico. And so what we're seeing is in this sort of improvement is actually it waffling back and forth. It's not doing much, unfortunately. And here we are again with that picture of where we are. Now let's look at what conditions have been like to get us to this point. I'm going to show you just a couple of maps. This is the precipitation anomaly over the last 90 days. This is winter precipitation. And what we see is that we've been really, really dry across Arizona, New Mexico, and in South Texas and up into Oklahoma. We're down in 10 to 20% of average in terms of precipitation over those 3 months. And keep in mind that this is a really important time, especially up here, once you get into the high country, for building some of that snowpack, for building some of that soil moisture across this region. And so it's been remarkably dry across this southern tier. And it's been wet across portions of the northern tier, the Central Rockies, the Northern Great Basin, much of eastern Oregon, and then much of eastern Montana too has been wet. We've had a series of atmospheric rivers, pretty normal for our winter conditions, that have come up through this central area. Notably, up here in the crown of the continent, in the far northern Rockies, where Glacier National Park is, and where we see the headwaters to the Missouri River Basin, the Columbia River Basin, and then up into the Hudson Bay area, we've actually been below normal in terms of our precipitation as well. Also notable is that this precipitation has tended to flow up north here and has missed much of the northern plains, including South Dakota, North Dakota, and Nebraska, with a couple of exceptions. We've paired that with pretty warm conditions across the southwestern United States and up into the Great Basin a bit, and across South Texas. Warmer than normal conditions. These are in deviation in degrees Fahrenheit. On average, there are portions of Utah and Colorado that have been upwards of 4 degrees warmer than normal on average over the last 90 days. So this is a warm winter pattern across the southwestern and southern U.S., a cool winter pattern across the northern Great Plains and in the central Great Plains, warmer than normal conditions slightly across the Midwest as well, and then a mixed bag across the South. Now, when you combine precipitation and temperature, you can talk about one of our leading drought indices, which is the Standardized Precipitation and Evapotranspiration Index. It's a big mouthful for just how much water is coming up out of the landscape. If it's warm and dry, we've got an evaporative potential, and we can see either more or less precipitation and evaporation, sort of the water balance for the landscape. Red in this map is drier than normal conditions. Dark red is much drier than normal. Blue is wetter than normal. And again, this is combining both that temperature and precipitation signal. So it's the water demand from the atmosphere. And what we see is that water demand from the atmosphere has been pretty dramatic across the southwestern U.S. We have this very narrow band of normal conditions, and then this wetter than normal conditions across the northern Rockies, and the northern inland Northwest. What we see up here is much warmer and drier conditions that have led to more evapotranspiration. And if there's snow on the landscape, this can be sublimation of that snow, where snow just evaporates off the surface, reducing your snowpack even when temperatures are below freezing, when the snow's not melting, but it can just evaporate away. This also happens in windy conditions as well. So what we've seen is that lack of moisture, lack of precipitation, and warmer than normal temperatures has really aggravated our drought condition across the southwestern United States. And this has also been reflected in our snowpack. I'm going to show you 4 maps from the Natural Resource Conservation Service. And this is of snow water equivalent as calculated from SNOTEL sites. SNOTEL sites are up in the high country. They're weather stations that measure the amount of snow water equivalent or water that's held within our snowpack. And what I'm showing you is aggregations of all of the SNOTEL sites across each of these major watersheds in the U.S. We've got the Missouri River Basin here. This is the Columbia River Basin and adjacent basins in the Pacific Northwest, the northern Colorado, southern Colorado. This goes down into the Rio Grande and the Red and Arkansas rivers. What we see is that, across the northern tier, we've been right at about normal. A 100 would be normal. If these were blue, we're above normal. We see some above normal conditions in California basins. But across these major southern river basins, the southern Colorado, the Rio Grande, and the Red Arkansas, we've seen much below normal snowpack conditions. Remember, this map is a little deceptive, right? We don't have much snow going on down here, but this is really capturing conditions in the headwaters. We can look at this at finer grained scales. So I'm going to show the next 3 maps are going to get tighter and tighter when it looks at where snow has fallen within these watersheds. And you'll see some of these eastern and southern tiers drop out of the map. They won't exist because we just don't have any snow down there. Here we are with the next level down, where we're looking at watersheds, and what we can see is that the headwaters way down here in New Mexico and Arizona, this is where we're really seeing that snowpack deficit. It's those high elevation areas, mountainous areas along these river basins, including the headwaters of the Rio Grande, have seen much below normal snowpack. We also see that here. And then this is our finest grain that's available. These, we call them HUC 10s, hydrologic unit 10s, but we can really see that there's a tight divide right through here where to the south, and this is right along the northern borders of Arizona and New Mexico. To the south, we have much below normal snowpack. To the north, much above normal snowpack, or average in these green areas. Up here, we've got much 200%. I mean, lots of snow up here. And then up here along the northern Rockies in Montana, what we've seen is actually a little bit below normal, right along the divide, right along where we get our most snow up in Glacier National Park. That's where we're seeing slightly below normal conditions. So the upshot here is that we've had a snow drought across the Southern Rockies. Now, why are we having that? Well, this year, oftentimes I talk about the El Nino and La Nina patterns, and I throw them some shade because about half the time it doesn't really pan out exactly how we talk about these patterns. But I'm here to tell you that this year we've had a very typical La Nina winter for especially the Western United States, where we've had some cooler and wetter temperatures across the Northern Rockies, and we've had drier and much drier and slightly warmer temperatures across the southern tier of the United States. Those are all the data that I just showed you. La Nina winters means less snow, more drought in the South. And in more snow and less drought in the north, and that's what in the western U.S. And that's really what we've seen. Here's our El Nino Southern Oscillation. Reds are El Ninos, warmer in the north and cooler and wetter in the south, and then La Ninas down here. which is the opposite pattern, since 2000. This is where we're at right now. We had actually predicted a slightly stronger La Nina. This was actually a weak La Nina pattern. And these are where the models are pointing us to going out through the end of the year. What you see here is a huge amount of spread. There is not a lot of agreement in our climate forecasts for where we might go in terms of our El Nino Southern Oscillation. What the average of all these models suggests is just over here. Let's see if I zoom in at all. No, I don't. What the average suggests is that we'll be moving back into neutral zone, neither El Nino nor La Nina. But really only time will tell. Some of these models have us continuing down into a deeper La Nina pattern. Other models have us spiking way back up into a strong El Nino. It really is a flip of a coin at this point. And that's what we see here. This is the official NOAA INSO probabilities going out the rest of the year. And what we see is most of the models, about 75% of the models, have us moving into neutral conditions. Some of them have us continuing in La Nina conditions. And then as we move through the year, we see some of the models going up 15%, having us go into those El Nino conditions. We actually see more of those models, almost 40%, having us drop back into another La Nina winter next year, and then about the same amount having us stay in this neutral territory. So again, lots of uncertainty with our El Nino outlook. We've experienced a weak La Nina. I can't really tell you what we should be planning for going into the future. I do want to point out, though, that there is an interesting pattern, and I've mentioned this on these calls before. There's an interesting pattern between El Niños and La Niñas and this sort of cycle of drought that we see. And I want you to focus your eyes in two places here. This upper tier, which these are our western basins, and then this, which is that same graph that I was just showing you, except smushed. And what I've noticed is that this drought cycle, where drought emerges in the southern plains and then moves through the Colorado River Basin, California Great Basin, the Missouri, and then out the northwestern corner of the country, tends to start after we bottom out, or as we bottom out in La Nina cycles, and then start emerging out of La Nina towards El Nino conditions. So and this is literally as the equatorial Pacific warms. So this is not causal. It's more whatever is happening at the global level that is causing our oceans to warm in this cycle is also causing our weather across Western North America to move through this arid phase in the way that we're seeing. And so as we emerge out from La Nina into El Nino conditions, we see during the same stretch, this here, and during the same stretch, this sort of cycle of drought restart itself. We are bottoming out possibly bottoming out in terms of a La Nina condition right now. And so this is where I'm saying that I expect to see a cycle of drought over the next year, maybe 2 years, go through the Southern Plains, Colorado Basin, California Great Basin, and then start really affecting us in the Missouri River Basin and the Pacific Northwest once again. So to me, we're restarting this cycle, and we should expect this trend to continue down in the south and then more into the north as we move into next winter. That is, unless we do dive back down into a La Nina, and then we should really expect that those drought conditions to linger in the southern tier of the country. All right, let's get into some of the outlook. I always show the 6 to 10 day outlooks because they're the most likely, where we have the most confidence, and then our confidence degrades as we go further out into the future. But here's what we're looking at for the next week and a half, is well above normal temperatures across the western U.S. I mean, way above normal, and way below normal precipitation, especially centered on the Four Corners, but really across the whole southern tier of the western U.S. out into Oklahoma and Kansas. Slightly above normal precipitation potential here in the Pacific Northwest. In fact, we're having an atmospheric river affecting us here in the Northern Rockies right now. It's snowing outside my window. Up to 2 weeks out, much the same pattern, a bit cooler and a bit wetter across the northern tier of the country, but still below normal precipitation and above normal temperature across the Four Corners region. As we move out to weeks 3 and 4, this is getting out to mid-April. We see that continuation of the above normal temperatures shifting a little bit to the east and really covering the entire Great Basin, and then below normal precipitation outlook across that same region centered on Colorado, with above normal precipitation outlooks here in the Pacific Northwest. Now we get into seasonal. So this is our spring outlook. And this is really matching that sort of emerging out of a La Nina pattern where we have above normal temperatures across the entire southern tier of the U.S., South Texas. I mean, Texas is just going to be hot as we move into our spring, and then below normal precipitation. Once again, the whole southwestern and southern plains region, much the same as what we've been experiencing for our seasonal outlook of spring. Our seasonal outlook of summer, June, July, August, hot and dry. So drought conditions are looking to persist, and that's what I want you all to really take away from this. We're seeing exceptional drought already across the southern tier. This is our drought outlook through the rest of the month. This takes those same climate outlooks and then casts them into what do we expect the drought conditions to do as they're assessed by the U.S. Drought Monitor. Brown areas are where we are currently in drought and we expect drought to persist. Yellow areas are where we're not currently in drought, but we expect it to develop. And then green areas are where we expect drought to be removed or improved for these sort of grayish areas. So what we expect is that the development of these drought conditions across pretty much the rest of Texas, and filling in some holes, including that little hole that we have in extreme northeastern Arizona and northwestern New Mexico. And then if we look out through the rest of April and the rest of May, the Drought Monitor is predicting that we'll see the continued development of drought conditions, pretty much filling in the map when it comes to the southern plains, when it comes to the central Rockies, and then moving over a bit into our northern Great Basin. So this is just following those climate outlooks of warmer conditions and drier conditions across this whole region. So we expect the U.S. Drought Monitor to follow suit. And this has real impacts on people when it comes to our forage availability, when it comes to our crops. It's going to be a dry summer. It also really applies to our fire outlook. And what we're looking at right here is what's called the burning index. This is an index that was created by our interagency fire centers, and really is a metric of how hard it is to contain fire once they start, contain wildland fires. Red here is where it's harder than normal to contain fires. Blue areas are where it's easier than normal to contain fires. This has to do with integrating both fuel moisture. So red areas are where we've got a lot of fuels on the landscape and it's drier, but also wind, right? It's actually an indexed on flame length. So if you were to have a fire start, how large the flames are and how quickly that fire can spread as an index of how hard it would be to control. And what we see is it's much harder to control fires right now across many of the areas where we've been seeing these fire outbreaks in West Texas, in parts of New Mexico, and we see over the next month the emergence of those really difficult to contain fire conditions moving up into the plains regions, the Front Range in Colorado. And so we're moving towards a pretty dangerous fire season across the entire country, but really centered on the southern tier of our country. This is the Wireland Fire Potential Outlook for March. This was issued on March 3rd. The next map, they update these maps only monthly. So the next series of maps will come out on April 1st. But what we see is that even a couple weeks ago, we were really predicting above normal fire activity and fire potential across West Texas, and Oklahoma, as well as eastern New Mexico. And our southeastern forests are also in danger or have a higher wildland fire potential right now, all the way down Florida. That continues in terms of into April, where we see a significantly higher than normal wildland fire potential. Also in southern Alaska, I just want to point that out, that we're seeing some higher than normal potential for fires in South Alaska as well. The May predictions are here. We see that moving out into more into Arizona, and then portions of California again are emerging as hot spots for our wildland fire potential. And then June expanding up into the rest of the Four Corners region. Currently, we're not seeing predictions of higher than normal wildfire potential across the northern tier of the Rockies, but we'll keep an eye on that. So that is what I have for you today. I'm happy to take questions. I'm sure you have them. And here's my contact information if you want to get in touch with me. Also, be on the lookout at native-resilience.com for this full slide deck, so you can bring these to your communities. I'm happy to take questions.
Thank you, Kyle. Okay, what questions do we have for him? Here's everyone.
I have a question.
Yes, sir.
Yeah.
Mike.
How you doing, Kyle?
Hey, good to see you.
Long time no see.
Hey, it's snowing.
Yeah, it is snowing. Hey, so what are you guys thinking about with the Trump things going on as far as fire responding or being able to respond to fires? I'm sure you're talking about it, but I don't know what.
I've heard a lot of chatter around here. We host the Fire Center, and many of our students and many people in the community here in Montana, in Missoula, are part of the firefighting community. I've heard a lot of rumors and a lot of chatter about readiness, but not much that I could really comment on. I would just say that it takes coordination and preparation, and some of the challenges that we've been seeing in terms of federal websites going down, data sets not being updated, those all impact readiness. Not to mention the cuts that we've seen in the federal government, and so I have concerns, but I don't have much insight into into federal readiness.
Yeah, that's what I was wondering, mostly about funding availability, if you've heard anything.
I have not. Does anybody else on the call care to comment on that?
I was going to say, Mike, that's a really good future topic presentation. Let me do a little research and see if we can't get someone that might know a little bit more about that to speak to our group.
Sounds good to me.
Yeah.
Just how do we respond? How do we, yeah.
Yeah, I'll basically say fire response amid cutbacks or budget.
Okay. Well,
Okay,
thanks, guys.
great.
I got to jump off. So, good to see y'all.
Thanks, Mike. Good to see
Have
you.
a good day.
You too. Thanks, Mike. Okay, any other questions? We're a quiet group today.
Quiet group.
Yes, it's okay. As always, if you want
I've got one right quick. I'm sorry,
Oh,
I didn't
good.
just didn't
Yeah,
get
Monty,
the
perfect.
I didn't get the microphone turned off.
Thanks, Monty.
Yeah, so Kyle, what about soil loss associated with drought after we've lost the grass cover? So
Well,
is there any way that they predict that?
do you know, as you know, once we lose grass cover and when we have dry conditions, it doesn't take much in terms of wind to lift those soils, and that's what we've seen in Oklahoma. I mean, saw a mix of wildfire smoke, but also dust storms, right? In these latest really high wind events, and so I haven't seen any maps or estimates. Maybe somebody on here would have a better sense of exactly whether there are any products out there that are actually estimating soil loss. But I think we've seen it, Monty.
Yeah.
You've seen it in the air, and that if these extra dry, hot conditions persist, which is all the data that's at our disposal is suggesting that they will, right? We should expect more soil loss with every wind event, unfortunately. So it's a big challenge that we have. Now, I don't know what the remedy for that is in places where we don't have vegetation, right? I mean, obviously, soil conservation practices can help where in places where those are already taking place, but if they haven't been, then you're already getting into conditions where you're at a real risk for topsoil loss.
Thank you.
I'm sorry I don't have any good good news for you. Has anybody here seen a soil loss prediction map or anything of it? I'm not aware of such a product, but it's
No, but that's also a great topic, Monty, that I think could go hand in hand with fire response and drought. So let me do some research and see who I can get to speak to our group on these topics. They're outstanding and they're very real, as we were talking about with the fire here last week. So
somebody from NRCS would be
right. And not only wind driven, but water driven when you get a rain on top of all that too.
Sure.
Yes, exactly.
And you get sedimentation of your natural tanks or man-made built ponds, and then you got other issues too. So,
well, and obviously, Monty, it's something that we really look at in terms of post-fire erosion, where we have these major fire events and we get denuded landscapes.
Nice. Okay. Let me do some research and see if I can cue some people up to speak to us on that. If you have a knowledgeable NRCS person, shoot me an email for anyone on here. We have a great one in South Dakota, although I'm just not sure of the knowledge because we aren't constantly in drought. So I think an NRCS professional that has more experience with that would really benefit us.
I think somebody in Western Oklahoma where we've been seeing where, I mean, we just had this event. It might be a timely,
Yeah.
it might be timely to reach out to them and ask about these broader patterns because they might be thinking about it.
Yeah, I will check. I got a guy over there that I think would know. So, okay, we will check into that.
Thanks, Keely.
Okay, any more? Great questions. Well, really, you just give me great topic ideas, which I love. Okay, we're going to give you 20 minutes back